Consider the following summation of a sequence: 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 and so on. The nth term would be 1 by n into n plus 1. So let us denote this by Sn. If you look at this, the nth term is 1 by n into n plus 1. I could write this 1 as n plus 1 minus n, and if I split this fraction I get n plus 1 by n into n plus 1 minus n by n into n plus 1. Some factors get cancelled and we get Tn as 1 by n minus 1 by n plus 1. So what we did here is we wrote the numerator as the difference of the denominator factors, so that the splitting into two factors becomes easier. Now this is of the form un minus un plus 1, where un is equal to 1 by n. So if you can write every term as difference of two consecutive terms of another sequence, then the summation of this series becomes easier. Let's see. Sn is t1 plus t2 and so on till tn. Tn I am writing as un minus un plus 1. So t1 will become u1 minus u2. T2 would become u2 minus u3 and so on. Tn would become un minus un plus 1. So minus u2 plus u2 minus u3 plus u3 minus un plus un. Most of the terms get cancelled and only two terms will survive, u1 minus un plus 1, which is very easy to calculate. So thus we find Sn. In this particular example, we can write Sn as, we wrote Tn as 1 by n minus 1 by n plus 1. So 1 by 1 into 2 I can write as 1 by 1 minus 1 by 2. 1 by 2 into 3 I can write, if I apply this, as 1 by 2 minus 1 by 3 and so on. Nth term I can write as 1 by n minus 1 by n plus 1. So all these terms will get cancelled off and we get 1 minus 1 by n plus 1 or n by n plus 1. So the simplified expression for this summation is n by n plus 1. We can also extend this. If you want sum of infinite terms, this part goes to 0 because 1 by a very large number goes to 0. So sum of infinite series in this particular example is 1. This method is called the method of telescoping, and also since you are writing every term as difference of two terms, we can also call this as method of differences.